at temperature T2 and pressure P1 and volume V1. Okay, this is placed like this, and now what we did is, now the gas is allowed to expand. Now what we did here is, this is like this, the gas is allowed to expand isothermally. Okay, if we allowed the gas to expand isothermally, then its volume changes to V1 to V2. Okay. The gas is allowed to expand, then its volume changes to V1 to V2. Now what we have to do, work done. We have to calculate, we have to derive for work done. Now the process is isothermal. Reversible expansion. For isothermal delta E is equals to 0. We know that delta E is equals to Q minus W. Okay, delta E equals to Q minus W, and 0 equals to Q minus W for this isothermal reversible expansion. Now Q equals to W. Here what we have to do, if W1 is the work done by the system, and Q2, because it is in the temperature phase T2, Q2 the heat absorbed by the system, and what happens here is, just see, W1 equals to Q2, but this is the ideal gas, that's why I worked on formula 4 according to ideal gas, but W1 equals to RT2 ln V2 divided by V1. That's what it becomes, Q2 equals to W1, hence Q2 equals to RT2 ln V2 divided by V1. This we call it as 1. This equation we call it as 1. It's 6 minutes 30 seconds. Okay. This is for what? Isothermal reversible expansion. Okay, we got for isothermal reversible expansion. Now the second one comes here is for adiabatic reversible expansion. Adiabatic reversible expansion. The gas the gas, after expanding its volume V1 to V2, the gas comes to point B. Okay. The gas comes to the point B here. Here, the gas expands from V1 volume to V2, hence it comes to the point P. After what we did is, we again allowed the gas to expand adiabatically, then its volume changes to again V3. Means volume again increases to V3, pressure gets decreased. Okay, we write here, in a heat reservoir, the temperature is T2. It starts to reduce when volume starts to change from V2 to V3. Okay. At point B, the pressure P2 and volume V2. Okay. Now the gas is allowed to expand adiabatically. So what happens if we allow the gas to expand adiabatically? Okay. The gas is here, the isothermal, after the isothermal reversible expansion, the gas comes to the V1 to V2. Then again, if we allow the gas to expand, the gas comes to the V3. The gas still more expands and volume gets increased. Okay. After this, we'll write here work done for adiabatic. Work done. It is adiabatic. The process is adiabatic. Hence, heat absorbed equals to 0, because temperature reduces, in the sense it should not absorbing the heat. Hence, Q equals to 0. We have the equation that is but delta E equals to Q minus W. Hence, this term becomes 0. W equals to minus delta E. But delta E equals to CV into the bracket T1 minus T2. Hence, what it becomes is now W delta E, then W equals to, this is the work done for second, W2 equals to CV into bracket T2 minus T1. Just here what we did here is, these are the pressure and volume and here is the isothermal. It is also isothermal. It is isothermal expansion, isothermal reversible expansion. This is isothermal reversible compression. And we got the 4 operations like this.